Mathematics, University of Sharjah, UAE, that is Muhammad S. Obedat Ji. Sir is Distinguished Professor at the University of Science and Technology, Beijing, China, and at the same time, Amity University, India. Sir is a professor at King Abdullah II School of Information Technology, University of Jordan. Founding editor-in-chief of Security and Privacy Journal, International Journal of Communication Systems, that are very publications related. And sir is editor for IEEE Wireless Communication and IEEE Systems Journal. He is the distinguished speaker of IEEE Computer Society, ACM, and SCS. He is an inductee of SCS Hall of Fame Life Achievement Award, recipient of the 2018 IEEE ComSoc Technical Committee on Communications Software 2018 Technical Achievement Award. Thanks for accepting and being the part of this continuous CCODE series, sir. That is an amusing welcome to Dr. Ezendu Araiva, that is Bedfordshire University, UK, and Prajit Datta, AI research scientist at AFRY, Sweden. At present, they are not joined, but they are going to deliver their speeches after this inaugural. Thanks to both of you for being the part of this conference. Professor S. Jyoti, Head of the Department of Computer Science, and colleagues of Sri Padmavati Mahila University, delegates from nation and international wide, and department scholars from nation and international wide, and students of this SPMVV, a very warm welcome to one and all who attend over this conference. Atmanirbhara Bharat, our self-sufficient Bharat, is the vision of our Prime Minister Narendra Modi ji. Making India a bigger and important part of economy, the 5 pillars of Atmanirbhar Bharat are economy, infrastructure, technology, vibrant demography, and demand. As a part, one of the pillar, and keeping in mind of our Chief Minister Sri Y.S. Jagan Mohan Reddy's interest towards technology, innovation, and incubation, the Department of Computer Science is organizing the 3rd International Conference on Computing, Communications, and Data Engineering, CCODE. Even UGC is insisting on the scholars do research which is essential to public, society, and community. As the part of this, we are invited the young minds to share their research contributions that are going to help society. During this pandemic period, some researchers, they came up with the new innovations like awakening us when we are not maintaining the social distance, and analysis of tweets with respect to the COVID data using AI techniques. Now let me allow to introduce just in brief about my department. We are offering the PhD, MPhil, and MCA in regular and self-finance mode with intake of 100. So far, 25 MPhils and 70 PhDs are awarded, and 70 students are currently doing their PhD. Among these, 9 are the international students. See, from this department, till now 6 patents are filed and 1 is granted. Our staff, 2 crores worth of projects are finished and 1 crore worth of project is currently going on. 5 crore funded project, funded technical incubation center is directed by our staff member. Now, thank you one and all. Now I request Professor P. Venkatakrishna, the convener of this conference, continue the proceedings.
Thank you, Madam. Honorable Vice Chancellor, Professor Jamuna Garu, respected Rector Sandhya Rani Garu, Registrar Professor Mamta Garu, our Dean School of Sciences, Professor Nagaraj Garu, the Head of the Department of Computer Science, Professor Jyoti Garu, and importantly, my guide and my guru, Professor Dr. Muhammad Obedat Garu, and the colleagues of Department of Computer Science, and the faculty members of SPMVV, the students, scholars, and fellow members. A very good morning to all of you. It gives me immense pleasure to address this particular gathering on the occasion of 3rd International Conference on Computing, Communications, and Data Engineering. Actually, the last 2 series were very successful. We could able to see each other due to the ongoing pandemic, the COVID-19. This time we are going on virtual. So this is also, this means that the pandemic doesn't stop us from working, irrespective of the various situations. we are able to pull through this particular CCODE, though it was a bit late compared to we are supposed to do in the month of April, but we postponed it, and somehow we could manage this year to conduct this third series of CCODE conference. And I would like to highlight some of the important aspects of the conference, as the conference is timely focusing on the themes like computing, communications, and data engineering, where we talk about the artificial intelligence, machine learning, data science, IoT, fog computing, and many interesting topics are there from various researchers are going to present in the coming days. So the conference has attracted many good number of submissions across the world. Good number of faculty members and research scholars have participated by submitting their papers, their research articles, which we are going to witness in the coming sessions. So we have divided into 3 tracks, having comprising of 70 plus articles, which represents reputed institutions like IITs, NITs, VIT, SRM, and the international institutions like Abdul Sattam University and Cookmin University, and many good international organizations also have come forward to participate in this particular event. So all the registered participants are giving the presentation either in the group mode or in the video presentation mode. The registered participants after the conference will be receiving your presentation certificates once you complete your presentation. The accepted papers will be published by the EAI core proceedings, which is going to be indexed in the Scopus and as well as Web of Science, and followed by additional opportunity is given to all the participants to submit their extended versions of the papers in reputed international journals, which are indexed in the Scopus and as well as Web of Science. So this is all about how we are taking the program forward. And I believe that this conference is setting a global platform for our local researchers. I mean, the people who are in and around Tirupati and Andhra Pradesh. It is giving a very good platform to interact with the international scholars, international eminent experts who are going to give their ideas. And they will talk about the current advances in the technology and how to handle the current situations like the COVID-19 situations. And here I appeal all the participants, I take this opportunity and appeal all the participants to develop and come out with the models, how to handle the situations like this using the technology. That is the computing and communications and data science has the major role to play. And this is the one which is helping the world in this current crisis, because the online classes, the virtual meetings, or the business, or anything that is all happening with the help of this particular technology. Right now, we know that usage of the masks, social distance holds the key in handling these things, and the technology is helping in order to come out with novel solutions in order to handle this kind of situation. And I believe that this particular platform also will give certain ideas for the young researchers, so that the deliberations of this conference will be much more useful to all the research community who present here. And we will take the benefits from the eminent speakers like Professor Abdait and other esteemed colleagues like Professor Araiva, Rajit, and many more members will be joining us later today. And with this brief, now I request our Honorable Vice Chancellor, Madam Professor Jamuna Garu, to give an inaugural message to all our participants.
Yeah, very good morning to everyone. Namaste from India to all the international participants. Today's keynote speaker, Dr. Mohammed Abaidat, Rector Professor Sandhya Rani, Registrar Professor Mamata, Dean of Sciences Professor Nagaraju, Professor Jyoti, Head of the Department of Computer Science, Invited speakers of this two-day international seminar, conference, Dr. Ijandu Arevia, Dr. Prajit Datta, convener Professor Venkat Krishna, and co-conveners Professor Usha Rani and Professor Sarita, faculty members of Computer Science Department, and my dear young participants and faculty members. Once again, very warm greetings from Sri Padmavati Mahila Viswavidyalayam. And at the outset, let me congratulate the organizers for planning this third consecutive international conference on computing, communications, and data engineering. For selecting, especially to select this relevant theme in the present day context. Well, revolutionary developments in computing, communications, and data engineering technologies in the recent decades made a significant impact on our lives. At the same time, there won't be two different opinions if I say that technology is invading in our lives. To say rather, we are becoming the slaves of today's technology, today's whatever technology it is. It has a tremendous and great impact on our day-to-day life experiences. It is indeed hard to imagine ourselves without it and how it is going to be, especially in the technologically advanced scenario in view of its wide range of applications in the areas like healthcare, education, industry, learning platforms, areas of surveillance and security, energy, transport, and climate, and so on and so forth. Especially, we have witnessed its relevance and its applicability and the utility of these technologies in these recent COVID-19 pandemic challenging situations. Well, to compete globally, the role of computing, communications, and data engineering technologies are important. To say it is detrimental in connecting past, present, and future to create a divergent platforms with a lot of applications for the benefit of the mankind. I'm sure the path-breaking innovations in the years to come, especially virtual realities through computing, communications, and data engineering technologies, would have a great impact on our lives, as I said earlier, and it will be tremendous. Well, the students, scholars, and scientists ought to be updated on these advances, especially in these areas. I wish the deliberations over the two-day conference would enrich the participants with a wealth of knowledge on recent advances in the areas of computing, communications, and data engineering. Wishing the conference a great experience. Thank you. Thank you once again.
Thank you, madam. Now I request our Honorable Rector, Madam, Professor K. Sandhyarani Garu, to address the gathering.
A very warm good morning to all. My humble greetings to our beloved Vice Chancellor, Professor D. Jamuna Garu. Today's keynote speaker, Dr. Muhammad S. Obaidah, Founding Dean and Professor, University of Sharjah, UAE, and other speakers, Dr. Ejunda Ariva, University of Bedfordshire, UK, Prajit Datta, AI Research Scientist at AFRI, Sweden. Thank you very much to all the three speakers for your gracious presence, and we are delighted to listen to your thought-provoking speeches in this conference. My warm wishes to Registrar Professor Mamata, Professor Nagaraju, Dean School of Sciences. I congratulate Professor Venkat Krishna, Convener of the conference, Professor M. Usharani, Professor Sarita, co-conveners, Professor S. Jyoti, Head and Faculty of Computer Science Department, for organizing the third international conference on computing, communication, and data engineering. Computing, communication, and data engineering are the prominent keywords in the field of computer science. I would like to share my views on the trends of computer science research. Computation and technology permeate our lives. Recent technological advances in sensors, embedded devices, and smart mobile devices, and in applications such as social networks, are making possible to pervasively capture huge amounts of data from many different contexts in both the physical world and the cyber world. Technologies such as cloud system, high performance computing, data analytics make possible to not only to share huge amounts of data, often referred to as big data, but also to process data for many different applications. Today, data is critical for scientific research. The research challenge is to identify the optimal trade-off between privacy and data utility and design technologies that achieve this trade-off. The availability of big data is revolutionizing how research is conducted and is leading to the emergence of the new paradigm of science based on data intensive computing and analytics. Data engineering is still an emerging area due to continuous advancements concerned with big data approaches where data engineer designs and builds data architectures for ingestion, processing, and surfacing data for large scale data intensive applications. Apart from few evergreen technologies, few technologies emerge at rapid pace due to dynamics of societal needs in 2021. I will share some of these technologies. The first one is edge computing, which is a distributed information technology architecture in which client data is processed at the periphery of the network as close to the originating source as possible. Edge computing addresses vital infrastructure challenges such as bandwidth limitations, excess latency, and network congestion. Edge computing is useful where connectivity is unreliable or bandwidth is restricted because of site's environmental characteristics. Examples include oil rigs, ships at sea, remote farms, or other remote locations. Next is artificial intelligence, which is already well known, and even in 2021, we expect AI technologies to grow exponentially and become part and parcel of all tech products and services. AI will be deployed increasingly in more systems which caters to health safety, and welfare of the public. These systems will better utilize scarce resources, prevent disasters, and increase safety, reliability, comfort, and convenience to the people. Next is virtual and augmented reality. Both virtual reality and augmented reality have a very huge potential in education, rehabilitation, entertainment, training, and marketing. Virtual reality and augmented reality are the top technology trends in 2021. Virtual reality immerses an individual in an environment, whereas augmented reality enhances the user's environment. Next is cyber security. Many people might be surprised to hear that cybersecurity has made it to top tech trends to look out for in 2021. But it definitely deserves its spot. Cybersecurity now dominates the priorities of every organization as they adapt to a post COVID 19 world. Remote workers' identities and devices are the new security perimeter, and cybersecurity technology is constantly evolving in line with hackers who are becoming ever more advanced. The innovation in computer science field not only address the current societal needs, but also keep an eye on the future needs of the society. I thank the organizers for giving me this opportunity, and I'm very confident the outcome of this conference is useful to the delegates and participants. Finally, innovation is a key to economic competitiveness, and the technological breakthroughs improve our lives. Thank you, one and all.
Thank you, madam, for giving a wonderful message on the occasion of our international conference. Now I request Professor Mohammed S. Wabadait to give his opening remarks about the conference.
Thank you, Professor Krishna. Namaste. Good morning in India. And I believe good Thursday evening in New York, New Jersey. Almost they start early morning, 1 minute in the morning of Friday. They are dealing with the election now in the United States. Good early morning in Europe. Good afternoon in Australia and New Zealand. Your Excellencies, Madam Vice Chancellor, Madam Rector and Registrar, Dean of Sciences of the Sri Padmavati Mahila Visvadhyalam University, distinguished deans of the university, faculty, colleagues, and guests, Professor Krishna, Professor Saritha, organizing committee, authors, presenters, attendees, especially our great students, ladies and gentlemen. Warm welcome to the 2020 International Conference on Computing, Communication, and Data Engineering, CCODE 2020, which was expected to be held face-to-face on the beautiful campus of the university, but due to COVID-19, here it's being held virtual. As stated, the key topics of this conference are crucial for any nation that seeks to have a place in today's digital and knowledge economy. I consider such technologies the oxygen that other technologies and systems need badly in order to operate in a reliable and cost-effective manner. Today's big data, smart cities and homes, smart systems, and critical infrastructures and key resources need these enabling technology on a daily basis. To build a city of the future that is smarter and more efficient, it is not enough to gather mountains of data on the state of its health, transportation, sanitation, education, safety, and security systems. To be of any use, that data needs to be sorted, stored, secured, and analyzed in real time in most cases. In some cases, getting results in real time means saving the life of a human being or saving a critical infrastructure and key resource that any nation needs in order to operate continuously and reliably. Expanding countries like China and India are undergoing exceptional urbanization as citizens migrate from the countryside to the mega cities like Mumbai, Delhi, Bangalore, Hyderabad, Chennai, Beijing, Shanghai, Chongqing, Xi'an, you name it. They are so large that make New York City seems quaint. In areas such as transportation and pollution control, computing, communication, data engineering, informatics, cybersecurity, AI, data science, big data analytics, e-commerce, biomedical informatics, business data analytics, robotics, modeling, and computer simulation technologies will be key to making these cities livable. Contracting countries such as Japan and Spain, meanwhile, must figure out how to meet the growing medical needs of their aging populations, perhaps through smart health homes outfitted with equipment that delivers insulin injection and monitors vital signs locally or remotely. One foreseeable challenge we can see is that the amount of data being generated in today's digital world is vastly greater than our capacity to comprehend and understand. We really have a tsunami of data. Big data has four major characteristics that often call the four V's: volume, variety, velocity, veracity. Volume, the size of big data is usually larger than terabytes and petabytes. Variety, various types of data with different formats. Velocity, two kinds of velocity related to big data that are the frequency of generation and frequency of handling, recording, and publishing. Veracity, which refers to the data quality and the data volume credibility, if you will. If you analyze information in a traditional way, it may take days to reach a decision. So we need smarter algorithms and technologies that will allow us to take the large volume of traffic data, analyze it, data mine it, search, compress it, secure it, and transport it fast in order to make timely and accurate decisions. Worldwide, so far, we still don't have really efficient algorithms and techniques to do so. There are also goals that are hard to reconcile. The Internet of Things, or the array of smart objects that are usually wirelessly connected to cyber, physical, and social systems and networks. Such network relies on processors with little memory and minimum computation power, as well as, in most cases, limited power, that is the limited battery life. Because of the object's limitation, you really cannot have efficient algorithms to protect the privacy, to design efficient encryption or, in general, security protocols, because such protocols requires massive computational power, and that could drain the battery of the nodes. So you really cannot have efficient algorithms to protect the privacy and security of the data, because an efficient security algorithm requires high computational power with large memory, which is in a way means a more sophisticated processor. Having the car of the future and automation and digitization of all processes in factories have become a priority to almost all nations worldwide. We need to protect our Earth from pollution so that we can live longer with no illnesses. COVID-19 has shown us how vulnerable we are in this world. Not only this, it has shown us that if we reduce emission of carbon dioxide, CO2, and be merciful to our Earth we live on, then global warming will disappear, or at least get reduced significantly. Our skies now look very blue compared to before COVID-19 visited us. So this international conference is tackling important topics that contribute to such goals. Participating in the conference as an author or attendee is a win-win scenario, as you will have the opportunity to learn recent advances and breakthroughs in related technologies and discipline from worldwide scientists and engineers. Even only from India, 1.36 billion people. That's a big segment of the world. As an author, you will be able to present your recent research results and share them with worldwide peers and get feedback for further enhancement. You will get new ideas for research topics, which is good to you as a student or researcher. You will make a new networking with worldwide peers. You will have opportunity to make partnership with worldwide entities at the level of your organization. You will find opportunities to have exchange visits with peers at other institutions and organizations. Hopefully, after COVID-19 leaves us, we can all travel. Students can find opportunities for internship and training, as well as graduate admission if desired in worldwide institutions. Postdocs can find research position in various institutions and organizations worldwide. Your university or college will have good opportunity to forge partnership with peer institutions worldwide in areas like dual degree programs, joint research proposals, among others. I want to thank all the organizers who make this conference successful. Special thanks go to the leadership of the university for the great support. And also we'd like to thank the faculty and staff of the university for their great efforts. Again, special thanks to Professor Krishna for his greater leadership of the conference. Thank you. Enjoy the program. Thank you all.
Thank you, Professor, for enlightening us with the ongoing technology and happenings. Now, the inaugural session of the conference comes to the close. Next, we will have the speeches from the eminent speakers in few minutes. So now I thank one and all who participated in the inaugural session, especially our Honorable Vice Chancellor, Madam Jamuna Garu, Rector, Madam Professor Sandhyarani Garu, Registrar, Professor Mamata Garu, Professor Nagaraj Garu, the Dean, Head of the Department, Professor Jyoti Garu, and all other my colleagues, faculty members. Thank you. Now, after the sessions from the experts, we will move on to the conference presentations and we will discuss about the issues. Thank you.
Thank you.
And I want to make the announcement that Professor Babada's main keynote speech will be there at around 2 p.m. He will be giving us the session between 2 to 3. So I want the participants to make a note of it.
Thank you.
Thank you.
See you later.
Yeah. Now, meanwhile, the speakers join us. If the participants have any questions to ask me, so I'm happy to address them. So now the inaugural session is over. Now we will have the speech from our eminent guests like Professor Ajindo Araiva and Dr. Prajit Datta. So they will be joining us any moment. Afterwards, we will proceed with the sessions, followed by afternoon a keynote speech from Professor Muhammad Wabadai, and later followed by the sessions. Sessions will continue, and the detailed program schedule is made available to you on the website and as well as it's mailed to you. If you have any queries, you can ask me. Now we will have the session from Prajit Datta on blockchain technology. He will be addressing us on blockchain technologies and its impact. And anytime we will start the session. I'm waiting for the speaker to join. So we have Prajit Datta here. It's my pleasure to invite Prajit Datta. Before that, I would like to introduce him to the audience. Good morning, Prajit.
Yeah, good morning, sir.
So let me introduce Prajit to all the participants. Prajit Datta is presently working as a research scientist at AFRY and currently based out of Sweden. He is also overseeing the AI Global Competence Group for the organization. Before that, he was working in GTO for Chief Data Scientist Organization at Bank of America. Prajit's corpus of work extends from the incorporation of artificial intelligence capabilities in different sectors to blockchain evangelism. He also works as a mentor for different developers as well as business communities. And along with all of this, he makes it a point to not to miss his social contributions through various outreach initiatives. But what really interests Prajit is the chance to interact with the passionate minds from all walks of life and the opportunity to influence them. He talks at TEDx platforms and other respected international platforms across the world. Have given Prajit a window to give back and multitudes to benefit from it. He has the vision to develop intelligence which will change the way we look at the world, or in short, to make person of interest. His belief in bringing a change to society has led him to participate and contribute as Global Shapers, a community supported by World Economic Forum, an author of 2 books, 26 Jump Starts and Startup to Scale Up. So he considered himself as Toastmaster for life. So this is a brief bio about our speaker today. He would like to give a presentation on blockchain technology and how it is impacting the current computing, communications, and data sciences. And I welcome from all the members of SPMVV, Prajit Datta, and I request him to give his presentation on blockchain technology. Thank you.
Yeah, sure. Thank you, sir, for the introduction. Hello, everyone. This is Prajit Datta, and I'm connected from Sweden. It's really early morning for me, and it's a winter time. So winter time, Northern Europe, and early morning, but always I feel it's like kind of I always like to share knowledge and share experiences with the students as well as with the community who have the aspiration to be part of the field. So today I'm going to talk about on blockchain. So when it comes to blockchain, I just wanted to give a quick I wanted to ask Professor, can I interact with students over chat, or how it is? Like, can I collect responses on throwing
Yeah,
some?
if you wish to.
Yeah. So there is nothing. Yeah, sure. So first of all, to all the students, have you heard of blockchain technology? Just if you can mention it in the chat, yes or no. I want to see the activity, because we would love.
Prajit, here many research scholars and students also are present. So we'd like to what is happening at the research front, and this is what we are looking at. Many faculty members, research scholars, and students, all mixed.
Okay, it's a mixed. Thank you.
Yeah, that's what.
Yeah. So in that case, then I will be speaking a brief on blockchain. Most of the people must be aware of if they are from the CS background or around that. And then I will be talking about what sort of business cases we are trying to solve it in Europe, and what sort of projects we are working on. So that is something like my talk will be revolving around. So blockchain, in short, it's a distributed ledger technology, which is immutable. I see one definition here in the chat. Thank you so much, Professor Shravani. It's a immutable distributed ledger technology, fast and transparent, have good high fault tolerance and all. Now, overall, the birth of blockchain took place, or the birth of blockchain happened during the 2008 financial crisis. And we all know about a cryptocurrency called Bitcoin. And the underlying technology that it uses is the blockchain. Now, there is this blockchain got empowered a lot more with an enhancement or with an addition of a special feature in that, or what we called it as something called as smart contracts. Smart contract is nothing but like a digital contract where you are programming some sort of a you're programming in such a way that contract that it can automatically execute and automatically tie up with the different owners, or there is an expiry date to that. There is something like there are some sort of an instructions or some sort of like a contract which automatically executable. So that is a smart contract thing. Now when this smart contract was was put over a blockchain, or where the blockchain was a carrier of the smart contracts, then the whole world found a lot of different use cases in different markets, different use cases. And I will be touching on those use cases, what we are looking in Europe. So the first use case with blockchain is basically the supply chain management. The supply chain data management, the SCM data, is something like is crucial, but it is not that critical like what we see in finance. And blockchain can give those, tracking capability, and what I will say, give those sort of transparency, um, give those sort of visibility, and also there is a lot of cost reduction. There is also enhancement of trust in between different parties. So a lot of the investments, a lot of the POCs, a lot of the prototypes being developed around the supply chain or the logistics industry. Different companies are trying it out and all. So you can think about when you order an e-commerce, or when you order something like from Flipkart or Amazon, you get some parcel delivered and you were able to track those information. Basically with the blockchain, what they are doing is that those information thread, they are putting it in the blockchain network, and then it is getting automatically more secure and more transparent, and we can rely on that there is no third party involvement in that after it is into the blockchain network. Now, with that being mentioned, SCM, a lot of things are happening in Denmark. There is one of the big logistics company called Maersk. They have also implemented blockchain. Now, moving on to that, which is the more prominent use case which we can see in the market is something called a fake news, blockchain and fake news. You must be aware of this. Fake news is creating a lot of noise around the world. People are saying that it is changing opinions of the people and then affecting the elections. It is also said that during this pandemic time, the coronavirus time, a lot of fake news are revolving around different sort of vaccination or different sort of thing. And people are kind of out of panic. They're consuming a lot of vaccine, or lot of unadvised, or lot of the vaccines which are not advised by any doctor or something around that. Or you can see that due to fake news and all, we create a wrong notion about some political figure, some personality, some celebrity, some country and all. And fake news is really a very big agenda, because it is actually creating a big socio-economic gap. The more socio-economic, the more this gap increases, the more it is difficult to kind of it's very difficult to it's very difficult to run that society with the proper democracy. Now with blockchain, what we have done, and what we can do with blockchain is basically we can track information. Now think about an article which is being published in the local daily like Hindu, and that article piece is is either written freshly by some author, or that article piece is something like that author is kind of, you know, is citing up some source and all which has been recorded in the past, or author is using any sort of media, whether it is in the form of image, video, or anything. Now think about, you are tracking those sources, you are tracking those information. Okay, this article has been written by this person, this article has quoted this are that old article, another article, and that article is having this sort of videos and all which has been taken by this person or this journalist, and so on. So basically what I mean is like a tree of tree which is actually highlighting the sources of information. Now when it comes to that, think about in this way that what exactly this blockchain is doing apart from this tracking the source, how we are able to detect the fake news here. So to be honest, fake news is something like, it's also kind of a perception of the readers at the same time. There can be some sort of fake news which are kind of, you know, bit tweaked in such a way that it makes it more, you know, impactful, or those like clickbait stuff, I mean, or they're totally fake or something around that. So currently we are in an era where there is a phenomenon which is called a circular reporting exists. Now what I mean by circular reporting is something like, think about a Wikipedia and think about I'm quoting from Wikipedia. Okay, this quote has been mentioned in Wikipedia, so I'm quoting it. And again, Wikipedia is actually quoting my code because Wikipedia is saying that this has been mentioned in the code. So basically, we both the parties are confirming each other by looking into each other. So that's what exactly it is. That's what we call it. That phenomenon is called a circular reporting. So fake news, whenever a fake news propaganda comes into the system, it becomes a victim of the circular reporting, and it started getting propagated more and more. Like it gets more viral because of social media. And there is a say that if you start seeing false a lot of time, then it started becoming true, right? So that's what it happens with fake news. Now this is a really, what I will say, very shame thing. It's a lot of shame, I will say, in the society currently we are facing. So with blockchain, what we can do that we are tracking those source, we are tracking those articles, we are tracking those people, and at the same time we are introducing some sort of a customer or the reader ratings. Now these reader ratings are really important. Like whenever you're reading an article, you cannot directly say that whether it's a fake or not, but rather you can check out the reader ratings associated with that article, as well as the articles or the media which that article has cited in that particular, you know, piece. So basically you can look into a lot of multiple things, multiple ratings and all, and based on that you can take a judgment on this, that whether it is a fake news or not. So that is something on fake news. There is one more project, a lot of things which are happening around the world is with energy sector. Now with energy sector in European in European countries, there is a norm that if an industry is utilizing some sort of an, or they're consuming some sort of an energy where they have kind of, it's something like the, what I will say, some sort of a slabs, you will say, or some sort of a quota. Now, out of that quota, if you are utilizing less energy, then you are provided with renewable energy certificates. Now, this renewable energy certificate is basically some sort of a thing that you are going green, or you are using less energy, or some sort of, you are creating less carbon footprint than what we were expecting or what your peers are expecting. And those renewable energy certificates you can actually trade in the markets and give it to the industry where they need a more for certain reasons or certain production reasons or something like that. So renewable energy certificate, REC, is one of the big markets, and it has been backed by one of the popular consortium, again based out of Europe, but it is getting good traction around the world, called Energy Web Foundation in blockchain. So Energy Web Foundation, they are putting up a lot of this sort of a protocol around the RECs, and it is happening. The same thing which is happening with another consortium called MOBI, which is an automobile consortium. Apart from this, there are a lot of technology foundations or non-profit technology foundations which are creating this sort of technological framework so that developers can develop around that, like Hyperledger, R3, and a lot more. So yeah, even Polkadot, I was just trying to recall the name this morning. Yeah, Polkadot. So even that is also one of the framework which is getting a lot of traction around the world. So it's a fight to different consortium and all. And why consortium are coming into the picture? Because when it comes to like blockchain, there are three types of blockchain. One is a public blockchain. Second one is permissible blockchain, or like kind of consortium, where it is not public, it is not entirely private, but it is something like a group of parties who have agreed on to be part of that particular blockchain network, so that you don't face any interoperability issue. So that is something which is going on. And the third one is a private blockchain. So consortiums or the semi-pervasible blockchain are this sort of thing. So whenever there is a blockchain with EWF, then all the energy companies are coming in, or they are trying to get, or this foundation, the people who run this foundation, they try to catch hold of a lot of these companies, or trying to create a good consortium, a stable consortium. Same with MOVI and all. Another energy use cases is with hydropowers. Now, in hydropowers, there is something called a gauge data. Those gauge data are nothing but a sensor data where they collect data from different sensors around hydropower plant. And those data points are really crucial, because these hydropower plants are not just a independent entity or something like that. They are connected in that particular network, right? So basically, based on the flow, water flow, and everything, the preceding as well as the succeeding hydropower plant need to kind of take judgment, and according to that, they can actually tune it up to the maximum efficiency of the power generation. So that's what the hydropower plant plays a great role in that. So with the gauge data, with the gauge data, like, or the sensor data from different hydropower plants, they are actually planning to create a blockchain data marketplace where they can sell the data among different partners or different, smaller, medium hydropower plants. Now, also in this whole system, they're also verifying the data which has been which is kind of they're adding into the blockchain network. That those gauge data, those sensor data, when they're adding into the blockchain network, they are responsible in verifying that data also. Because if you know how sensor works, then there is a high possibility that these sensors, they're not always accurate. That is also a, I will say, a big flaw in the system. Now who will take care of that, whether these sensor data are accurate or maintaining some standards? So basically, there are some sort of a hydrological protocols or hydrological formulations are there which check up the thresholds, and based on the thresholds they take up the judgment. They take up the judgment that whether they need to feed the data in the blockchain network or not. Because once the data is being fed in the blockchain network, it's very difficult to, it's actually not very difficult, it's kind of not so advisable to kind of change the data every time and all. Then it's a really tedious task because it's a ledger data, and also you need to build that sort of a system around that. So this is one thing companies are working on. Another very interesting case which automobile industries are doing, because I'm from Gothenburg, Sweden, and it's basically a Volvo city. So a lot of autonomous vehicles and all we see. Now with autonomous vehicle, you must have heard that this autonomous vehicle are the real future. It's not because that they just drive you automatically to one place to another, but also it can be seen in such a way that they are doing they are obeying the traffic rules more, and also they are accessible to anyone, even to some people who don't know driving. Autonomous driving should not be seen in such a way that you are driving and just you leave your steering wheel and then it is just guiding you. Autonomous vehicle, I'm talking on the stage 6 level, where the vehicle is taking or what I will say, like it's following up its own track and and taking you to one destination. Now with autonomous vehicle and all, how blockchain is incorporating in this whole ecosystem is, or getting incorporated in this whole ecosystem, because it's something like, you think that you are driving a Tesla and you drove the Tesla and went to your office. Now your car is being parked at one parking place. Suppose take a scenario that your car is fully autonomous and it just roams around the city by itself, and it is also part of some network where people can book that car and go from one place to another. In the whole process, it started earning money for you. So that is the future actually. It's not the future like where the Uber or Ola are there in the markets, where with one tap in the app you can just call the driver and the vehicle and you are moving from one place to another. The future is going to be autonomous, and that's how it is going to look like. Now when it comes to autonomous vehicle, there is also a possibility that of identity theft, right? Someone can use your vehicle or something like that, they can hack anything, or they can steal your credentials and kind of um change up all the ownership and take control of the whole vehicle. With blockchain smart contracts, this sort of thing is really difficult, really very difficult. Your identity as an owner will be very much preserved, and nobody can hack extra from external side unless they know your credentials. We came across a lot of Bitcoin news that some sort of a some sort of a hacking happened, or Bitcoin got hacked or something like that. Someone has lost this much money, or the market has lost this much money. This is basically because they were able to find out the entry level credentials to enter into the market. It's not because that they were able to hack the blockchain. Even with another thing called Ethereum, they were also working on that, and of course it is unhackable, but there was some issue with that Ethereum, and then they had to return that investment. Why it happened? Because again, I say that blockchain is basically a protocol, and they couldn't develop that Ethereum, or they couldn't program it so well that, you know, it was just holding up the, it was just holding up the, or it was just following the real protocol of any blockchain network, which is cryptographic, decentralized, and all cryptographic chains and decentralized. So so that is the case going on, you know. This is what exactly we can do with blockchain. And yeah, these are like the main use cases. Also the autonomous vehicle and ownership I have mentioned. Of course, we can see also a lot of financial blockchain implementation in financial banks and all. But with the financial banks, what we realize as the year as many years passed by, we witnessed that as you know, financial data is so crucial and it's so private data that it's not advised to just put in blockchain network, because it is also needs to be kind of scrutinized well, and also it needs to be checked out whether they are following all the rules and regulations in that particular jurisdiction or not. And that's the reason banks are a bit hesitant with blockchain. But whenever we see that there is some sort of a semi-transparent data, any sort of ecosystem wherever we see a semi-transparent data network, there only we can kind of introduce this blockchain network and make it more secure, and, you know, and look into different opportunities. One of the popular blockchain technological framework, as I mentioned, is Hyperledger. Hyperledger Fabric has created a good development platform, or has been recognized as a good development framework in the markets. Lot of different sort of I will say applications are being created around that. Last, I would like to conclude my speech with one very important story. I would I want to share with you. I personally feel that blockchain is actually a really big revolution. Then it's a very big revolution than internet. Now, I want to explain it why and how. So with internet, you can think that people are having access and all, and smartphones, and in India we have got Geo. It's so cheap internet, right? But it is not possible everywhere. Internet is a really costly effort in a lot of countries, and also it creates a big socioeconomic gap between the people who have the access to internet and who don't have. It's something like you can figure out, you can see the information, you can check everything, and you can read. But someone who don't have the access of the internet, then they can be misguided and all. Like think about people in rural villages and all, right? They can be misguided, or, you know, because they cannot go and fact check, or they don't have the easy access to the information. So with that being mentioned, there is a big socioeconomic gap is actually creating, like the silos are being created. And with blockchain, it will not happen in that way. To give a more better picture of what I'm saying is, think about 1947 when India got independent, and then the Industrial Revolution picked up really well in India, and people started moving from villages to cities in search of job, and or maybe basically in search of an industrial opportunities and all. In the whole process, a lot of people have left their a lot of people had left their ancestral land, and believe that their relatives or their own people will take care and a lot of these things, and they thought of building their own family in the industry cities and all, in the industrial cities and every like that. Now what happened that after these people, when they kind of they thought of when they are settled up and everything, like they thought of going back and trying to do something with their ancestral land, or maybe after retirement go and see how is the status and what is the condition and all everything. A lot of these people, when they found that this sort of land being uh, being are now being or being looted by the mafia, local land mafia, they were able to forge the documents and everything, and they are just claiming that it is their own land, and they're like mafia, right? So they are with weapons and all, they just rule that place with lot of power and political support and everything. Now those people, they are just industrial labor and all, and they are they are fighting the litigation and putting up the cases in the court. It takes a lot of money. It's not a cheap affair actually. It takes a lot of money. And think about people from like a lower middle class and all, like whether they should go for a job or whether they should focus or put up money and wait, and the judiciary system takes a lot of time, which is really messy. And at the same time, judiciary system believes in proofs. Now if someone has created a complete forged document like of that land, then what sort of proof you can provide to to claim that that land belongs to you? Now this is a really messy thing, I would say. So with that being mentioned and all, what blockchain can do in this regard? Think about a farmer's land registry information is stored in a government blockchain network, and government can kind of, that information is secure, so government can see the records and then they can take a judgment and all. And at the same time, even if that farmer, it doesn't matter that whether he knows how to use blockchain or not, whether he has internet, he is connected with internet or not, it doesn't matter at all. His rights are preserved. So basically, with that being mentioned, it brings a social equality. It brings, it reduces the gap, a socioeconomic gap which was not fulfilled by internet. So with that being mentioned, we can see that blockchain is actually a bigger revolution than internet, where rights of every individual in the whole world will be preserved if we can use this technology in a really rightful direction. And that is the power of that. So with this, I'd like to thank you everyone. This was a 30 minutes talk from my end, 35 minutes talk from my end. And again, I'm sorry, it's so early morning and it's a winter season here. I'm not used to with that, but I hope that I was able to share my thoughts and knowledge with you. And I'm open for questions or anything. If you feel free to ask me over chat or by unmuting yourself. Over to you, Professor.
Prajit, you are done?
Yes.
The session is done? Sorry.
Yeah, the session is done, sir.
Yeah, now I request the participants, anyone has any questions to Prajit, you can ask, or you can type in the chat window so that he can see and answer directly?
Yeah, so someone has asked me that where to learn blockchain. So basically, I will suggest that if you wanted to learn blockchain, then go and Google about Hyperledger tutorials. Then
Yeah, maybe you can type that so that people.
Yeah, maybe I can share that complete link only. So here you can go and check out different tutorials on blockchain and see and learn, and that's how you can go ahead with that what you can do with it.
Yeah, how blockchain is useful uh, in developing various protocols in IoT and other upcoming fields like machine learning, AI, how this is used. Can you throw some light on that?
Blockchain is not like they are like more of a, I will say, like it's not um, it is a more of a complementary solution with them, like with the data being properly in shape and being tracked, then you can use an AI over that. And when it comes to IoT and all, then you can kind of create have a blockchain network and have that ownership of that IoT network, and also you can see in that way that like in supply chain network with the use of IoT devices and all, you are feeding the data directly into the blockchain network. So basically it's more of a complementary thing where it is just leveraging the utility of the blockchain to a bigger extent. That's what I can say. That's what it is there in the market. Yeah.
Sir, one question. I am Dr.
As a question, anyone?
Sir, one question, sir. I am Dr. Keshav Reddy.
Yes, sir.
Sir, there is a difference between wireless sensor networks and blockchain network. The difference wireless sensor networks to blockchain network.
Can you please be a bit more louder? I cannot hear you that properly.
He is asking what is the difference between the wireless sensor network and blockchain network. That is his question.
Okay, so wireless technology is totally a different technology. So it's a communication technology and all, you can see. Blockchain network is basically, I will say, like a file storage system or something around that. So, but why we call it as a network? Because it's a decentralized network where the information is being kind of replicated and put up in different nodes, and this network are connected through cryptographic chains. Wireless network is totally altogether a different sort of a hardware communication system, but blockchain system is like basically a blockchain is a file system, what I will say.
So it is a distributed ledger.
Sir, here is the questions in the chat box. Hello, sir.
Yes, ma'am.
Have you taken any steps to collaborate with government? Some Sandhya Madhuri, she is asking to our speaker. Have you taken any steps to collaborate with government?
So yeah, in Europe, we work with a lot of different public procurements from different governments, and there is a lot of funding around that, especially with the sustainability and the blockchain initiative, especially with the European Union and a lot of collaborative research forums. Like in Sweden, we have Vinnova and RISE. And those sort of things are there. And yes, And moreover, for a blockchain type of thing, you need to push consortiums, and those consortiums you can only do when you have a proper government support. So that's how we have taken. But when it comes to like Indian government and all, like from our side, we have not done much yet. And moreover, currently, few of the, I think when I see about which governments are taking steps, then I think like government of Telangana did some step with blockchain technology. I'm not sure that how was the implementation stage or where they are now. But sooner or later, a lot of different governments around the world are taking. So in India also, we can see a lot of things happening in the near future.
One more question from Dr. Sandhya. What are the protocols used in blockchain technology?
Like there are multiple, it depends actually. It's again, I will say it's very much depends on what sort of technology framework you're using. And it's not I will say like you can, it depends on, I cannot just comment on single thing. There are so many multiple sort of multiple different type of blockchain there in the market. So you just need to see that what sort of protocol you want for your thing. So you can, it will be different for Fabric, it will be different for Sawtooth, R3, based on the utility and functionality.
Thank you, sir.
Yeah, sure.
Any queries from the audience?
Anyone has questions to Prajit? Okay, then thank you, Prajit, for giving us this morning a wonderful talk on blockchain technologies. And all, we wish you all the best for your career. And it's very good to see you at the third series of CCODE. Of course, you are there at the first presentation of CCODE, first edition of CCODE. And now you are here virtually. So good to see you. And I hope our collaboration will continue, and our participants would like to interact with you, maybe offline also. They may contact you if they require some help on blockchain and related technologies. So lastly, sorry to bother you at this early in the morning to connect us, though we are now at almost 11:30 in Indian time.
It's 11:30. Yeah.
Okay. So really, the session was very useful and informative to all our participants. And once again, thank you. Thanks for your support.
Sure. Thank you so much, everyone from my side. Thanks for the opportunity, and feel free to connect me with me on LinkedIn. And yeah, thank you. Take care then. Bye.
Yeah, thank you. Thank you. Madam, just give me 1 second. The speaker is calling. I will, 1 second.
ఎవరైనా ఏదైనా క్వశ్చన్స్ ఇక్కడ రైజ్ చేశారా?
సార్ ఏజెండు అరవై గారు వచ్చారండి.
Hello, Professor. Professor, are you hearing me? Tarun? తరుణ్
సార్ వినిపిస్తోంది సార్ వినిపిస్తోంది.
ప్రొఫెసర్ ది మ్యూట్ లో ఉందా?
అవును సార్, నేను ఇప్పుడే కోహోస్ట్ చేశాను సార్, మ్యూట్ లో ఉన్నారు.
ప్రొఫెసర్ అరైవా.
Hello.
Yes.
Yeah, I can hear you.
Sir,
Yeah, hello.
Hello. Warm welcome to you.
Thank you very much.
Yeah. Sorry for the mistake. The timing difference between India and UK. Anyway, I take this opportunity to welcome you. A warm welcome from the CCODE conference, and thanks for joining. And now, all the participants, let me take this opportunity to introduce Professor Ejindu Araiva. One second. Yes. So this is my pleasure to introduce Professor Ejindu Araiva, University of Wales, Trinity St. David, UK, postgraduate research supervisor, chair IEEE Consumer Technology and Broadcast Technology Chapter, UK and Ireland, chair IEEE Technology and Engineering Management Society, UK and Ireland, associate vice chair, BCS Health and Care Executive. And let me briefly introduce Professor Araiva's biography. Professor Ejindu Araiva is a fellow of British Computer Society and chair of IEEE Consumer Technology and Broadcast Technology Chapter, UK and Ireland. He holds the post of postgraduate research supervision at the University of Wales, Trinity St. David, London campus, UK, and previously held the role of academic supervision at Warwick University, UK, and also coordinating international research and director of studies for doctoral research project supervision. He has excellent research project supervision and curriculum development records and completion rates, including external examination roles in UK and internationally. He also undertakes international research and sponsored consultancy projects, including executive training workshops for top government executives. In addition, he holds the position of Deputy Vice Chancellor, Academic and International Outreach at the University of Management and Technology, Sierra Leone, and previously held the role of Director of Planning for International Outreach at IIM Tech University. He also held various academic and professional positions with many years of experience in the United Kingdom and internationally. He has a good research profile and founding editor-in-chief of International Journal of Green Computing, editor-in-chief of the International Journal of Computing and Digital Systems, and associate editor of IEEE Consumer Electronics magazine. Ejindu is author of a number of books and papers published in international journals and conference proceedings. He has also delivered keynote speeches at various international conferences. He recently published a book on green technology applications for enterprise and academic innovation by IGI Global. So we have the honor of inviting Professor Ejindu Araiva to this particular August audience. And Professor, a warm welcome to you. Now, Professor will give a talk on green technology and its impact to the world. He will be addressing us. Professor, please.
Thank you very much. Thank you, Professor Venkata Krishna. Thank you for inviting me to this distinguished and honorable conference.
Professor,
I will speak.
Switch on your video so that all our members can see you.
Okay, so they can. Okay, I didn't know that. Okay.
Maybe you can adjust your cam so that.
Yeah. So I hope you can see me now. Can you?
Yes, yes. This is perfect.
Yeah. Good morning, everybody. Yeah, it is nice, and thank Professor Krishna for inviting me to give a distinguished keynote this morning. I think it's still morning. We are in India now. We're just maybe afternoon time. I don't know. I've actually moved on the day, so time difference. So I will speak on green technology issues, and I will spend a couple of minutes to explore those disciplines and its applications to both data engineering and implications for global context with respect to CSR. I will just get my, I don't know if you can do sharing. Can you do it here? Or to be able to see this? I can talk. You want me to talk through or just for sharing slides so you can see what I'm going to talk about? Let's see this. See how that works. That plays up now. Next few minutes. Hope I don't lose this. Okay, let's see. Document sharing. Yeah, it comes here. Let's see. Let's see. I think I'm still there. Hopefully. Here we go.
Share screen here in the opening screen. It is available.
Sir,
is it? Did you
voice
say?
is not clear.
Not clear.
Where is sir? Voice is not clear.
Sir, it will be, sir. Yes.
Just give me a few minutes. I'm just gonna get back to it.
So next to chart, it is there. Share screen. Next to chart.
Okay, I'm just gonna get that. Just give me 1 minute. I'm just gonna adjust this quickly. Just a few minutes. I'll get that on. Just a few minutes.
Or you can proceed, Professor. Without
can I proceed?
Yeah, you can. No issues.
Let's see. Just give me 1 minute. I can just get back. 1 minute. I just get it back.
Okay.
See, just 1 minute. I'll get this in. See if that works. Just 1 minute. I think it's gonna work. Just 1 minute. I'll take one of this. Now comes up. Just there. Just trying to get this in. God, just 1 minute. It's gonna come up. Taking time.
Or you mail us, Professor. We will share it for you. If you can mail it.
Yeah. Okay. Okay. So let's get this thing. Hopefully, if it doesn't, I'll just talk through it. Is that okay?
Yeah. Okay. You can switch on your video.
Yeah, that's what I'm trying to do now. 1 minute. Come on. It doesn't. Okay. Let's see. Show to work. I ran the test a few minutes ago and it works. Now, get this on again. I think 1 minute will get up. 6. Come on. Let's see. 6. This is not good. Problem does not. Yeah. Okay. Let's see. I'm just trying to. Let's see. Which file is out? Video. Okay, I'll just get back there. I just want to get this down.
Are you mail it to us, Professor? We will share it.
Okay, I think I got it.
Okay.
Just 1 minute to get it set up. It's gonna come up. Just 1 minute is there. Come on. Where's it going? Okay, yeah. Okay, here we go. Now, I just put it on in the okay, I think I'll go down to share now. The work. Okay. Okay. Let's see. Okay.
Or you can
Okay, I think it's this. Okay, let's see. Okay, now let's say here. Let's say your share video is here, is it right?
Sir?
Here is here.
No, sir.
Yeah, it is sharing. Yes.
It's sharing now.
Yes. Yes. Now it is.
You sure? Let's see. Is it share? Is it right?
Yes.
Okay.
You can take the presentation mode.
Okay. Let's see. This keyboard is playing up now. Okay, let's see. Can you see? You can see that?
Yes, we can. We are able to see.
Okay. So sorry about that. I just trying to get it on stage, and I hope it will respond okay. Yeah.
Yes.
Think it works well. Is it okay now?
Yeah, perfect.
Okay, thank you. Sorry about that. Just have to try to figure out this thing sometimes. Okay, sorry. Just trying to focus on some key issues this morning, which I think quite important for us to share, and through your expertise, either contributions, innovative practice. We focused on green technology, environmental sustainability, and then we reference to microplastic pollutions, which we know is quite important. That's a video coming to me, is that right?
Yeah.
I think that's right. Okay. So, we now will, in this discussion this morning, we focus on the key agenda, or what you may call the key discussion issues. We'll focus on green technology strategy, looking at strategic issues on green technology in the dimension. We'll look at the taxonomy, the principal models that drive green technology within this concept of data engineering, pollutions, and environmental factors. And we'll look at the microplastic pollutions and the impact of it on the society we live today. We'll as well examine the digital healthcare matters and smart living, as we think those applies to the concept of environment and data relationships. We then focus on climate change, which is a subject that's very, very hot today in our disciplines, irrespective of what field you're studying from. And then we then focus on the issue of environmental sustainability. At the end of all those, we then have to examine the business case for deploying green technology within the context of microplastic pollution environment and the data exploratory concepts there, which has to do with data engineering. And then we'll hopefully get to a conclusion and look at the viable models for that conclusion. And then further work that we hope to look at within the discipline. Then the first thing we then talk about is green technology. As early as green technology started studies all over the world, as far back as 2010, 2009, we find out that it's very difficult to have a harmonious views on green technology. In about 2010, I was able to visit a couple of research colleagues, as well as I was able to make a visit to Professor Krishna Venkata in those days, looking at the setting up of green technology centers and the impact in engineering. Then here you can see that if you go into research dimensions there, the first kind of definition you can see in our green business or green technology or green computing has always been the views of our work in 2011. And if you can see today, there have been a lot of explosions to this kind of concepts from different researchers, different scholars, and especially some practitioners have got their views on it. Then we can see here that we focus on green technology in the context of various environmental issues. We're interested in our environment and trying to look at data exploratory issues in the environment and how to save the environment that we live today. We can always look at the issue of global warming and the various kind of changes in the concept of things in the environment and heat exploratory systems, high sea rising levels that we know has got a high impact. And we can see the melting of the ice all over in different kind of the Iceland concepts to keep the environment stable. Then we then focus on the social impact and political. Irrespective of the political dimensions, we need to look at the views of those in government and the investment and how they focus on these green computing matters with reference to their policies and strategies and engagement with the world and the people that they govern with respect to effect and efficient use of energy. Energy can be another kind of issues for us and achieve competitive advantage in terms of energy cost savings, strategy, and reduction to carbon emission and carbon footprints. And we now look at the issue of recycling, which is again issue for us, and biodegradability and minimal impact on the environment. All these theories are quite good, but then you ask yourself how many countries, how many organizations are really following these principles and theories, or how many homes are involved in recycling principles and being able to think about the environment and what we do. We claim that we are quite aware of environmental impact and we're aware of the way environment progresses, and we're part of those energy saving groups. But the viability of that is still to be measured and to see such impact. In the United Kingdom, it's quite important that we recognize the element of environmental issues and data exploratory issues, in the sense that you cannot go to any shopping today in this country. You really have to use your plastic bag, and now we're trying to ban plastic bags in shores because of its impact in pollution in the high sea levels. And you can look at the marine engineering. Most of the sea um, environmental resource issues have really suffered heavily on big oceans. You find most of the fish and whales feeding on the plastic, and that's quite dangerous for their own health and well-being. So that again is an issue. And recycling and over those kind of issues is very important for us as well. We know how that in the United States, New York had a very great principle of shopping where everybody has to use paper bags. And you're thinking about paper bags. What are the impact of paper bags on the environment? How do we get the paper? You then look at the trees that we chop down to be able to get on these papers. Then how are we managing to save the environment if we're going to try to cut down the trees? And you can see a lot of wildlife fire issues that are happening both in the United States and in Australia. So these are all about global warming and climate issues. Then what we said, look, green technology cannot only, or green computing, the only way we can look at them is under the condition of the 3 E's. And our 3 E concept focuses on efficiency. When you deploy this principle, it's going to make sure that it is effective in its context. And what is the equity or return on investment or value analysis? You've got to have some values on this. It's easier to ask someone to engage on green computing or green business. Then the next question you want to ask yourself is, how does this impact on the programs and the activities that they are involved in? Then you can then say that we now refer to green computing as environmental responsibility. It's going to be environmental responsible using computers and related resources. If we ask people today, how many people remember that when they left their home this morning, they switched on their computers, but now we're all working from home. So if we have more than one computer, how are we managing these processes? Then here we try to look at our world data issues in terms of how much plastic enters the world oceans. The measurement of how much plastic enters the oceans is quite difficult. It depends on which country you're dealing with and what are the impacts on the life animals on the sea. So that again becomes very important for us. Then here we're thinking about the digital health and smart living. Then if we look at digital health and smart living, we're trying to say, how do we use energy saving strategies to sustain our own well-being and our health, which is very, very important. So we now can say that to work in that direction, we need to look at health and well-being, and we need to look at security issues. We need to look at our daily living, especially with this pandemic. Our day-to-day activities and health and well-being become very important, especially any part of the world that you live in. If you live in the developed world, or you live in India or China or any other part of those places, you can see that we now have all the lockdown from time to time, trying to make sure that the pandemic doesn't affect us so much. But what is the impact of that? The digital healthcare and smart living concept for us with pandemic theories is that we now get used to trying to stay at home more than everything and work from home. And that it has an impact for itself in terms of the health. We're now having one way of preserving our work through computing development and trying to sustain the environment. And then in the other way, we have an impact on our health. And then the social inclusions activities that we're involved in a wider environment has been reduced. Now we can see that in future, at the end of this pandemic, we're not going to have few other people having dependency on healthcare. And what are those dependencies on? Those dependencies will vary with respect to mental health issues and different kind of health matters that will develop. The one I thought is that what are the challenges for this sort of research areas or deployment of this kind of areas? The key challenges we face is about the way we develop our future practitioners. One of them in terms of research and scholarship. We really consider research and scholarship very important to understand how the green technology, the pollution principles will be handled and managed. Will the universities alone do this work or higher education institutions? Then we go into the knowledge modes concepts, mode 1 and mode 2 knowledge. The theoretical framework for students to develop in their research areas or scholars or fellows. And then the other part is the collaboration with industries under mode 2, where we have researchers working both in the industry as well as engaging in higher education institutions or colleges. This is a very good model, mode 2 theory for a good model for in Germany. All professors in Germany spend at least 1 day a week in an industrial sector. This happens in other countries with a partnership. In the United Kingdom, we have the Society of Engineers sponsoring academics to work in industries and bring those knowledge back to the classroom. So that is the only way that we can see the progress in the discipline that we're dealing with and its impact with the environment. Learning and teaching theories, how do we change our teaching practice to engage the learner with these principles within the discipline and professional bodies' views on this. Positive team relationship, there should be team relationship building. Even now we are working on this webinar conference. We can now see we're building a better network and we're trying to address a problem. And this problem has some challenges. And we're engaging as a team and building partnerships so that we can engage in maybe bidding for fundings or grants or consultancies to address those kind of problems that we've identified. Provide clear vision driven by missions. We need to have clear vision. We're going to deal with these sort of topical areas. These are topical areas that are current, that are challenging, that have got impact on our own lives, and impact on businesses, and impact on governance. So high expectation in terms of the output of the society. To improve the environment and sustainability issues. Then we improve the environment in one way, but at the sea level, and the other environmental of pollution rules and the cars that we design. Then how sustainable are those over time? If we have electric cars, how many places do we have the charging points for electric cars? You know, we may have electric cars in places, and eventually the support of those cars become an issue. If we have cars using petrol, or we have cars using diesel, so the pollution level goes down. And the age of the car has an impact on the environment. We provide time and opportunities for collaboration. Collaboration is very important, both with industry and different kind of platforms. We distribute leadership and build a team. You know, we really have to build a team on the discipline of research to engage on these topical areas of concern. Engage the institution's executives. You have to engage with the vice chancellor, with the chief executive, in whatever you're doing, or the dean and head of department to understand. They will understand where the resources will come from for this sort of research, and then try to draw inspiration from the industrial sectors and government. Evaluations and innovative practices. So we really have to evaluate whatever practice. That's why in our first key indicators, we looked at the business case. You're not going to convince anyone why you need to invest on something or research on a particular area where there are no benefits of it. That comes a return on investment on the development. Return on investment, value addedness. So how do we address this? And how do we demonstrate that the research we're going to execute in this area is innovative in terms of its practices? Not for theoretical framework or writing texts or books and people read, but what is the commercialization factor in terms of partnership and patents? Then we're looking at this research excellence model when we come to situations like this. In our research excellence model, we're thinking about, yes, if we have a mission, we have to identify the differentiating factors in our mission to come to research excellence. Then one, how do we achieve those areas? What are we talking about? Specializations in the areas. So if this discipline is a specialized area, these are people talking about data engineering, these are specialized disciplines. But how competitive is that discipline with today's world? How? So how do we measure the indicators for that? Do we have access to data to be able to measure how competitive the field is? Then we think about responsibility and accountability for this. Because if we don't have accountability and responsibility, it will be very hard to think about coordination processes. It will be very hard to think about decision-making processes. It's very hard to engage on the operational mechanisms. And then it will be very hard to measure and think about reflections on our audit trail, reflect on the transparency of our research discipline and share of knowledge. And what are the elements of due diligence? That's our commitment to that. When quality becomes an issue, what are the measurement indicators of quality? Who values those? And that's why I mentioned about patents. We patent, we go to accreditation, we go through the ranking, and we engage our groups in training so that they work at the same level to develop work in this discipline that we're concerned with. Then we then think about how do we focus on all this? We look first at our challenges, we then can see opportunities from our challenges. Not only on a global trends or global platform, we as well looking at the local, community-based issues. But the problem most cases we have is people are thinking about the globalization concept. Then if we work on a globalization concept, what are the local and capacity building platforms? And if we look at that, we can say one of the key things is research is an issue. How many people are involved in those research areas? What are their contributions? Learning and teaching. How has our research informed our learning and teaching? What are the job market issues? Quality, funding, and then how do we gain access to those kind of research areas in terms of dealing with populations or industrial engagement or government sponsorships? Then I will just leave this model and then take you back to what I call the key attributes. The key attributes that we think in the research area like this has to do more in terms of energy efficiency. Then what are our theory of energy effectiveness or energy efficacy? What are our alternative energy systems? What we're trying to do is to draw kind of platforms and have indicators for alternatives. If you cannot provide efficiency in terms of energy distributions when it comes to hydropower systems based on our population and user groups, then how do we look for alternative energy platforms? How do we look to reusable energy? For example, how do we then engage ourselves to wind power systems, to biofuel energy generations, wind power systems? How do we really deal with this? And that's the problem. The solar systems, to what level? The PVs for car parking or element of security lighting. Do we have access to those? Do we invest on them? So I'm not talking about efficiency of energy, but looking at the impact of it to the environment and human lives. Climate protections. We need to develop environmental models for climate protection. If we don't protect our climate, we're going to have serious problems. And then the resources that we reserve for other activities will be wasted because our climate will then be attacking us. If we want to build houses on a kind of areas where we know we have sea levels, how do we now use constructive engineering to rechannel the sea and reclaim the land? Not really doing it out of this, but over time that the sea comes back and get all our customers and going out of the sea. Transport and logistics, we looked at electric cars, alternative modes of transportation with energy savings, self-driven cars, port cars. Those are useful ways of developing our environment and trying to build a new green concept. Carbon reduction, use of carbon index, how do we return some of the products that we have and how do we dispose them? I read in a journals recently where a young child in primary school was able to develop radio transmitter in Sierra Leone by going to the bin to pick up a lot of rubbish in the waste disposal areas and was able to build transmitters. But what we have not considered, we've looked at the knowledge from this young person, but we've not considered the hazardous and toxic waste that the young person has gone through. We've not thought about this. Carbon reductions and use of carbon index. Then recovery and recycling. E-waste and disposal strategies, very important in today's development in green technology and green computing. And then how do we harmonize the data engineering this concept and effectively utilize them? Product life cycles, how do we then look at our product life cycle systems In those days when you start the system development life cycle, you're not really thinking about your disposal. You're not looking about your waste. You know, so those are new dimensions that we need to build our e-waste and our disposal strategy into our life cycle of development and design. And user needs, I mentioned about user needs, multiple uses concepts, and sustainability impact to social enterprise. How do we now convert those waste to a social enterprise in society? How do we take waste from one aspect to the next aspect to become usage product? How do we recycle those products? You know, materials that we don't need. How do we recycle them and come up with a new blended material? Human factors. In order to drive this forward, human factor is very important, and we need to develop what I call awareness education with respect to behavior management of individuals. So if we create that level of awareness through education, through training, not only at university level, but at even primary level. You know, citizenship is done at primary level. So why can't we teach corporate social responsibilities to young children at primary education? So when they get to secondary, they do another level of it. When they get to the university or college, another level of it. Then when they graduate, they be good practitioners. They observe these theories that we are teaching. But the problem society is having is that we lump a lot of these new ideas at university level, higher education level, and eventually the younger generation doesn't know what we're talking about. Then I thought that for us to progress on this concept, we need to now focus on being able to use our renewable energies effectively, and we need to build up a sustainable model. Innovation in terms of research and development becomes very important. And environment, we cannot avoid the environment. We need to consider environmental issues at all times. That should be the focus of whatever we do. And how would we do this? Build collaboration between industries, between higher education, between fellows in the university. Not only that, between government, so that we can have pressure on government through our research to change the system and the policy that we've identified. They will have country and country collaborative principles, the UTOM platforms, which is very, very effective. If you look at most of the developed countries, you can see it a lot of partnership in terms of working together and sharing those concepts. And United Nations focusing on these principles that look, environmental issues is very important, green technology is very important. Every country must really demonstrate how they are practicing this. The way we have looked at the energy consumption theory, that every country must show 50-something% of adjustment or alternative energy usage. So that by 2050, they must have gone to low-level energy consumption level and low-risk platforms for energy generation. Then we thought that the key indicators were based on those theories I've mentioned. Then second level is strategic indicators for deliverables. What we've built into that model is thinking about continuous professional development in healthcare and professionalism, which is very important. We cannot talk about all these changes without professional engagement and professional bodies that will really address some of the research that we intend to do. Research and innovation and development of quality. That's very important. Collaborations and internationalization, I mentioned on that. Countries, partner countries, share of education experience, knowledge hubs and partnerships, and then knowledge partnership with sustainability platforms, climate change, and environmental issues. So I think that's where I will just stop this morning or afternoon, wherever you are, and then maybe take a few questions on our key indicative principles that we are working. Thank you very much.
Any questions from the audience to the professor? Anyone want to, even they can send a message?
Yeah, they can send messages or, you know.
Thank you very much, Professor, for your enlightening speech today to our participants. It was really interesting to know about the various key strategic indicators about green technologies and its impact in data engineering, etc. I believe the participants should have benefited from your presentation. It is excellently presented to all our participants. Let us take, if any, one or two questions are there from the participants before the session concludes. Anyone? Okay, then I think the people are not having the questions now. I think they may be writing to us. If there are no questions, then let us conclude the session. Once again, I thank you, Professor Ejindu Araiva, for gracing this occasion and giving your wonderful speech on this ongoing topic. Very important topic it is, on green technology and its constraints and various aspects. Like Professor has enlightened us on like sustainability, healthcare, and how the climate changes, environmental issues, and followed by the research and how the research community should respond to all the open challenges that are out there. And I believe these outcomes will be taken by all the participants, and they will be working in this particular domain. Professor, there is a question is coming. Professor, there is a question: how to build a frame using the green technology implementation in image analysis, particularly in healthcare? There is a question, Professor. Would you like to answer that?
What is the question, please? Can you go through it?
Yeah, it is there in the chat box also, but anyway, I will read it for you. How to build a frame using the green technology implementation in image analysis, particularly in healthcare framework.
How to build a framework or model. Is that what that means?
Yes.
In healthcare.
Yes, exactly.
In healthcare, we have always done some work on digital healthcare with the healthcare sectors. We looked at various kind of training programs that we require in healthcare, and the resources deployed by clinicians. The classical example I'll give is, if you look at the new dimension in healthcare, both support strategies in healthcare. Most of the materials used in healthcare today are recyclable materials. So our model ensures that most of the materials or clinical resources deployed in healthcare for Medicare of patients has to comply with recycling materials that has less impact or in terms of generating hazard on the health of the individual. So that not after an individual is treated in medical sectors, they will then recover from the illness, but the impact of the resources used for that individual can create other illness over time. So we've really been able to be looking at that aspect, and we've really done a lot of work with digital clinic groups in UK, as well as the Council for Healthcare Practitioners, trying to see how healthcare benefits from this. And if you look at there was a model I brought up initially, which has to do with healthcare. If you look at the issue of the present pandemic, we're looking at people are working from home, then we're looking at low-level energy consumption resources or materials used by individuals at home, because we do know that lack of exercise to individuals, even when at home, can lead to mental health problems. So that becomes a problem in society. So the green technology is saying, look, you're gonna use a recyclable systems, you're gonna use low radiation materials, you're gonna use electricity facilities that are probably of low impact to the health of an individual. So if you have a green technology model for healthcare framework, you cannot be looking at its sustainability, its impact, its energy consumption, and its reduction to different kind of health ailments, things like mental health. You understand? I can use different models in green technology, coloring systems, change of models, so that the brain and the body system will get harmonized as a healing principle for meditation. So there are different kind of approach we've looked at. We looked at the ethical impact of it to individuals. We then looked at the framework that harmonizes with the individual, and products used in treatment in the hospitals or dealing with health should not be hazardous to the environment. Disposal framework should be properly done. There should be a way of recycling processes that have no impact and disposal processes for things that are hazardous.
Okay. Any other queries to Professor? Okay. So thank you very much, Professor, for giving us a wonderful session today. And I take this opportunity to, on behalf of Sri Padmavati Mahila Vishwavidyalaya, to extend my sincere gratitude to Professor Echendu Araiva for accepting our invitation and delivering a wonderful keynote speech today for all of us. And with this, we are concluding the session. And later to this, we will have presentations from the participants, followed by afternoon, we have another keynote from Professor Mohammed Obedaid at around 2 p.m. Between the lunch break, immediately after the lunch break. So this is what the today's session, and I request Professor M. Usharani Madam to continue with the presentations. So thanks, Professor.
Thank you much.
Yeah, thank you.
Bye.
Good to see you.
Thank you. See you soon.
Yeah, please.
Yes, sir. First candidate, Sandhya Madhuri. Are you ready, ma'am?
Yes, ma'am. Ready, ma'am.
Yes, share your screen.
Yes, ma'am. Good morning, dignitaries, my dear scholars, and all the invitees to this wonderful conference of CCODE from our prestigious university, Sri Padmavati Mahila University. It has been my privilege that every year my guide, Dr. M. Usharani ma'am, is giving me an opportunity to participate in this conference. This time it is virtual, but yet we could connect with all the people. Thank you so much for the opportunity. Now I'll start my presentation. My name is Sandhya Madhuri. I'm research scholar of Dr. M. Usharani. Today I'm going to present my topic. I have given a paper on anomaly detection techniques using massive online analysis tool. So I'm going to give that presentation now. I'll share my screen. Ma'am, can I start?
Yes. Just side to chart box, ma'am.
Yes, ma'am. Am I sharing my screen now?
Yes, keep it in the slide mode.
Yes, ma'am. Yes, good morning once again. My topic is anomaly detection techniques using Moa. Moa stands for Massive Online Analysis. This is a tool which has many machine learning algorithms we use to detect anomalies. First of all, let us see what is an anomaly basically. Any deviation from whatever the normal data, we call that as an anomaly. Suppose we monitor a health device, we connect a health monitoring device to a patient, and we continuously take the data from the patient. Somewhere if we suddenly there is a deviation from the normal data points that we are getting, we call that deviation as an anomaly. We can also check such kind of anomalies in our credit card frauds or sensor alarms or any condition monitoring devices. So a problem like anomaly arises when usually we try to monitor a machine or a particular data that we are receiving continuously. How can we detect anomalies? Anomalies can be detected using many techniques. There are so many statistical approaches. There are so many machine learning approaches. There are so many deep learning approaches also. When it comes to machine learning approaches, I'm right now focused in data streams. My research work is also in data streams and detecting anomalies in data streams. So my paper consists basically focuses on anomaly detection in data streams. Basically, there is a difference when we try to find out anomalies from a static data to which of that of a streamed data. So why that is why basically the difference? Because the data is always evolving, always the data tries to change. For every second the data is changing, so we need to monitor the data for every second, and we need to find out what is normal data point and what is a anomaly data point. We also called anomalies as outliers. So I have taken this tool called Massive Online Analysis Tool. This is from the Weka University of New Zealand. From the Weka tool, what we have already learned from the Waikato University, New Zealand. They have this tool called Massive Online Analysis Tool, which continuously monitors data. It works basically with data streams. This is a software environment which we can implement algorithms. That is, we can compare two algorithms run on a continuous data stream, and we can check which algorithm is performing better. Basically, the parameters that we usually try to check here are how much time it is taking for each data point to be checked, whether this is a normal data point or whether this is an outlier, and also how much of CPU memory are we, how much of memory are we using, how much of time are we allotting, and the total how many range queries are we giving. So these are the parameters we check and we decide which algorithm is performing better in this tool. So Moa has the following algorithms which you are seeing right now on the screen. Basically, all these are working on these are all distance based algorithms. So MCODE, basically microcluster based continuous outlier detection. This in our observation, when we have put so many algorithms and we have compared with all the algorithms and with different data streams, not only synthetic but also real-time data, but also data sets that we got from Yahoo and all, we have figured out that MCODE is performing better than the other algorithms when it comparison. So basically Moa workflow is like this. It's very simple. First, the data stream is chosen. It is and it is configured. And second, an algorithm or a classifier is assigned, and then the parameters are set. And the third one is we finally measure the results. So this is the basic framework of Moa. And this is a typical setup how it looks like. Basically classification, clustering, outliers. I'm only focusing on outliers here. This is how we set up. You can see on the screen I am checking whether what is the difference between MCODE algorithm and annually exact storm algorithm. So basically I'm trying to figure out what is the which algorithm performs better in these two. This is how we set it up. Basically the tool looks like, the interface looks like this. And these are the parameters we take. The important ones basically are the radius of the cluster and the neighbors of the clusters. These are the basic parameters that we pass in Massive Online Analysis tool. And this is how it looks like when we complete the running of the algorithms is done, and we checked our right now it shows that it has checked 1,000 data points, and that's how the normal and outliers are detected. You can see the red points are all the outliers and the gray points being the normal points, and right below you can see the graph on which algorithm performs better. The red one denotes for the first one, the blue one denotes for the second one. So which algorithm performs better, we can have a comparative graph or time taken for each object, each data point, how much time it is taking. That's the graph that shows below in this visualization. So thank you. This is my presentation. This is my paper is all about. Ma'am, can I stop sharing now?
Wait.
Ma'am,
any questions from audience? Sandhya Madhuri, what is the data as you took to examine your framework?
Ma'am, I have taken basically 3 types of data. Ma'am, I have got Yahoo data where they have given us a time series of data. I have applied for Yahoo and they were ready to share with us. So I have taken that. I have also taken synthetic data. The tool itself, the Moa tool itself generates data streams continuously to let us compare the algorithm. So I have taken the synthetic data from there. And also I have taken KDD data, data discovery data, that these 3 data I have passed, and when I have put in the tool, it is continuously passed to the algorithms to check, and that's how I have come to the conclusion that an MCODE algorithm performs better.
MCODE algorithm is performing better.
Yes, ma'am. Based on the time taken.
On all these type of data.
Yes, ma'am. On all the 3 types of data.
Okay. Any questions from the audience? No questions, I think. Sandhya Madhuri, you are presented well.
Thank you, ma'am.
Yes, congrats.
Thank you, ma'am. Can I stay on mute, ma'am, now?
Unmute.
Thank you. Thank you so much. Thank you, everyone, for this opportunity.
Next person. Jabin, are you ready?
Good morning, ma'am. Yes, I'm ready, ma'am.
Yes.
Okay. Can I share my presentation, ma'am?
First, come into picture. Sandhya Madhuri, please unmute yourself.
Good morning, ma'am. Good morning, one and all. Hello. Can you hear me, ma'am?
Yeah. Introduce yourself and start your presentation.
I'm Jabin Sultana. I have submitted my thesis at Padmavati Mahavishwavidyalaya in the Department of Computer Science Engineering. Today, I am going to present a paper titled Prediction of Sentiment Analysis on COVID data using machine learning and deep learning techniques. Let me share. Can I share my screen, ma'am, to show the presentation?
Yes. Share your screen.
Okay, ma'am. Is it visible, ma'am?
Yes, keep it in the slideshow mode.
Yes, ma'am. So, thank you. First of all, I would like to thanks for giving me this opportunity to present paper in this 3rd International Conference on Data Communications and Engineering, CCODE 2020. My title, Prediction of Sentiment Analysis on COVID Data using Machine Learning and Deep Learning. And the contents today, abstract, literature survey, and how we have collected data, followed by proposed methodology, results, and discussion. In present times, deep learning techniques are widely used by the researchers to perform COVID data classification, clustering, and further aid in as these techniques help in diagnosing COVID. So a lot of research is going on these days using machine learning techniques, using deep learning techniques. So till date, there are 8.36 million COVID-19 cases registered in India and approximately 124,000 deaths. And simultaneously, we are having in our country India, we are having good recovery rate also, as we are having strong immunity power, and because of some other reasons also. So actually, as we the whole world is suffering due to COVID, it's widespread. Some people are largely affected, and some people are lightly affected and recovered. So all these things led us to carry out this research. As this deadly virus is rapidly spreading in India and affected lives of many people, many businesses, labors, all because of lockdown and all. It has affected lives of all the people in various walks of life across the world. Especially in India, it has affected. Why? Because in India, 80% of people a source of income is based on businesses, small scale industries and all, and 20% of people actually have jobs, and they like they are earning from a secure governmental organizations, and remaining 80% depend upon industry, depend upon small size businesses, etc. So this COVID virus lockdown and other things have affected our country's economy, and also it has affected in educational sector, in business sector to a huge extent. This research work used the coronavirus related tweets of Indians to analyze the sentiments of Indian people towards this deadly virus and its impact on people. So we thought of collecting sentiments of Indian public towards this COVID, how people are dealing with this, and how lives are affected with this, starting from children, young people, and old age people. We have collected tweets, sentiment. We have used search keywords like Indian COVID, COVID, or life of people after COVID. Like that, we have used search keywords, and we have collected, extracted many tweets. We have pre-processed, we have cleaned the tweets, and later we have classified the tweets based upon the polarity, positive, negative, and neutral. And a ladder tweets classification was done using holdout method. We have performed training and testing, and it was we have used machine learning classifiers and deep learning classifier, and we have observed that deep conventional deep learning method, MLP, has outperformed in classifying the COVID tweets with attaining 97% accuracy. For this research work, we have done extensive literature. We have studied uh, various COVID related papers, as these days lot of research is going on COVID. Many papers have been published using machine learning techniques, uh, and deep learning techniques, and other techniques also, clustering, association rule mining, support vector machines, and we have seen various literature survey. uh, After undergoing through various as per reviewing the above papers, we thought of classifying and analyzing Indian COVID-19 sentiments and, and problems faced by public in different walks of life, and how COVID has affected the lives of Indian people. So data in the form of COVID tweets are extracted from Twitter using Twitter API in this research work. Tweets were extracted and pre-processed well by removing hashtags, punctuations, quoted text, URLs, stop words, etc. In Python. Later, tweets were classified based on polarity. Dataset was classified into 3 classes. Experimentations were done using Vega. We took to a COVID tweets dataset. We have converted the tweets dataset into numeric form, and we have applied class machine learning techniques and deep learning techniques. We have applied decision tree, naive Bayes tree, multi-layer perceptron, and AdaBoost. As Veka can proficiently work with limited data, and it is very widely used in data mining. So with using Veka, we have performed classification. Dataset was taken in ARF format, and this is our proposed methodology. Initially, we have collected tweets, then pre-processed well, classified, into proper class, positive, negative, and neutral. Then we have selected machine learning classifiers. We used holdout method. 75% of data set was taken for training and 25% of data set was taken for testing. And after testing, the model obtained the results. Results were evaluated based on the matrix, accuracy, precision, recall, and F score. And the best classifier yielding high accuracy is identified. Machine learning techniques like decision tree, naive Bayes, and AdaBoost are used for training and testing. 70% of training data and 30% of test data. We performed 75-25 also, but we got best results on 70% of training data and 30% of the test data. And these are the methods used: decision tree, naive Bayes, multi-layer perceptron, and AdaBoost. And these are the result analysis. uh, Naive Bayes obtained 73% in classifying COVID tweets, Indian COVID tweets. Decision tree obtained 75%. AdaBoost obtained 89%, and MLP obtained highest 97%. Also, roots mean square error in classifying the tweets. Naive Bayes got 0.32%, decision tree 0.35, AdaBoost 0.21, followed by MLP. MLP is having least root mean square error. In terms of precision, naive Bayes has obtained 0.72, decision tree 0.74, AdaBoost 0.88, and here also multi-layer perceptron obtained the best results in terms of precision, recall, F score, ROC curve, and kappa statistics value. Followed by the results were followed after MLP were AdaBoost. AdaBoost has obtained 89% classification accuracy with 0.21 RM root mean square error, and precision rate 0.88, recall rate 0.89, and kappa statistics value 0.80, followed by decision tree. Although decision tree performs very well in classifying, but here it failed to give good results, as decision tree has obtained 75% classification accuracy, and error rate was high, 0.35%, and if precision recall 0.7475, kappa statistics 0.52, and naive Bayes also, it is a state of the art method, but here it failed to give good results as data set was large in size. Accuracy it gave 73%. Usually machine learning techniques work well on small data sets. They fail to work on large data sets, and deep learning techniques work very well on large data sets. And obviously we don't use deep learning techniques for small size data sets. So overall, these are the accuracies. Multi-layer perceptron obtained high accuracy in terms of classifying COVID tweets, followed by AdaBoost decision tree 75%, and naive Bayes 73%. Conclusion: due to widespread of social media during this COVID-19 pandemic, most of the public have preferred Twitter to share their sentiments related to this COVID-19 virus, SARS, and it spread right from diagnosis to getting cured. Before this COVID, we have different, we have this syndrome, SARS and all in the Middle East syndrome. In Middle East area, it's like a dust syndrome. But this COVID-19 is something like novel coronavirus, which has affected the lives of many. Although it's not a although public analyzing the tweets of the public, we have we have extracted that although this is not much affecting, but people have a scaredness because of this, as they saw lot of deaths in the initial days. So people are scared yet about this COVID-19 virus. This research work, we have collected tweets from Twitter, and we have performed classification, and MLP has attained 97% accuracy, and well quality tweets we have analyzed, which reveal that public is avoiding social distancing at rural places. public is avoiding social distances at urban areas, but at rural places, public is not maintaining social distance at all, not sanitizing well due to lack of amenities, as they don't have as they don't have basic things to reach out. So it's highly impossible for them to maintain well sanitization. But still, our government of India is working very hard for this we got from the tweets. And the main thing, one more quality tweet which we analyzed was private schools in India faced were challenging tasks to collect fee, and at the same time this resulted in affecting the salaries of teachers, as schools did not get proper money from the students, and this ultimately led to the salaries of teachers and maintenance, and high profile teachers, they were at risk of the job, and many people are getting less than their actual pay scale because of this problem. And some students are unable to pay the fee because of xyz reasons like their father's income, etc. And some students at the same time, they are unable to learn the full concepts. Why? Because usually till last year, till December, January, before the lockdown actually began, children, and mostly in India, we had as traditional classroom teaching. Our students were attracted to that, and they were convenient with that. Now suddenly the change in online, even though they are learning, but they are not able to learn 100% full concepts. This was also analyzed. And students at rural areas of India face technical difficulties. Special needs students lack in learning the concepts well. And at the same time, many business, right from small vendors, small scale to high, were affected. It's some or how. This was what we have analyzed. And scope of future work for this paper is to improve the accuracy of state-of-the-art methods, decision tree, name base in classifying quote tweets. Also, we plan to work on some other data related to COVID. Like here we have collected tweets. In future, we plan to work on image classification. We plan to work on images of chest and this is how we have planned for our future work. And these were the references I have followed for this work. Thank you one and all for giving this opportunity. I thank my guide, Professor Usha ma'am, for guiding me at each and every stage. I'm very grateful to you, ma'am. Thank you once again. Thank you, Venkat
From the
Krishna.
audience.
Thank you, Venkat Krishna, sir, convener of this conference. Thank you, Rector ma'am. Thank you, Chief Guest, and everyone. I'm wholeheartedly very happy and delighted to share my research work on this platform. Thank you.
Actually, I have to congratulate to you, Jabin, because on this platform, as soon as you submitted your thesis, you are not kept quiet. You are continuing your research, and at the same time, the research, whatever as you are doing, it is helping to the society community. Okay,
Yes, ma'am.
keep continue. Right.
Thank you so much, ma'am. Thank you. Can I leave, ma'am?
Yes.
Any questions, please?
The next person, Bhavana, is ready.
Yes, madam, I'm ready.
Yes.
Okay, ma'am, I'll leave from here.
Should I share my screen, madam?
Yes, yes, yes.
Okay, ma'am.
The scholars who want to present at this time, okay, after 1 o'clock, that is 1 to 2, it's the lunch hour. After 2 to 3, Muhammad S. Obedat, he is giving his keynote speech. From 3 o'clock to, you may continue your presentations. Okay?
Yeah, ma'am.
You may continue.
Good morning, everyone. I'm very thankful to the committee of CCODE to give me the opportunity to present my paper. I'm Bhavna Dhupia, a research scholar under Dr. Usha Rani. And my topic is today assessment of electric consumption forecast using machine learning and deep learning models for industrial sector. So the presentation will go on. It will be an introduction first, then the contribution of my paper, then methodology and result discussion, and then the future work. So this is like machine learning and deep learning plays a significant role in the area of predicting energy consumption. We are seeing that machine learning and deep learning are contributing towards the prediction analysis in any field. So we have chosen ML and DL for our research project also. So energy consumption forecasting is one of the major contribution towards the smart grid management. My work is on smart grid management, and these days, these two fields are contributing very well in this field. So it helps energy stakeholders to take important decisions on technical and economical issues, as Dr. Ariva told in the presentation, that green energy is they are projecting green energy, and it can help in improving that green energy issues also. So smart meter contributes majorly for collecting the detailed consumption data in smart grid. So the data collected for my research is from smart meters. So the contribution of my paper is, the main contribution of the paper is the comparison between a DL and ML model in predicting energy consumption for short term. So I have used ML and DL algorithms to predict the energy consumption, and the comparison on the most popular evaluation metrics. So I have taken the data and run those models, DL and ML models, and I made a comparison between the two results, and the evaluation metrics are R square, mean absolute error, mean squared error, and root mean squared error. So ML models used are linear regression, random forest, and decision tree. So I have chosen the traditional ML models to see the prediction analysis. So I choose LR, RF, and DTR. Then I did a comparison between the best, after getting the best result from ML models, I compared the results with LSTM based on RNN model. So here is the methodology. I collected the raw data, then pre-processed the data. I clustered it, I normalized the missing values and checked the outliers and processed it to get the right result. And then I applied traditional machine learning models that, as I told you, decision tree regressor, random forest, linear regression. And then I compare the results. I compare the results of decision tree, random forest, linear regression based on R square, MSE, RMSE, and MAE. Then after comparing the result, I run the same DL model on the same data, and then compared the best ML model with LSTM RNN. So the best result here. So first, I would like to give the description of my data. So the data is real time, and it is collected from HPSEB, Himachal Pradesh State Electricity Board for industrial sector for 2 years. As they are implementing smart meters and they started with industrial sector, so I got the data only from industrial sectors only. So total data samples collected are 4.5 millions. And first I clustered, because the data is huge, so I clustered it based on k-means into 4 cluster. And then I taken 5 companies, means 1 from each cluster, and then 1 randomly I chosen it, and from the data set. The attributes taken into considerations were meter ID and consumption. As I have got the data with 5 attributes, but then I took the major feature, the main feature, which can contribute towards my research. Then consumption is recorded for every 15 minutes of timestamp. So the data taken, the data collected is through smart meter, and it was taken on every 15 minutes of timestamp. So for all the processing, the pre-processing of data, I used Python 3 with Keras library. TensorFlow is used for analysis with Google Colab. As you see, the data is huge, so it is difficult to work on my laptop. So I took the Google Colab Cloud, so because it is giving 16 GB of RAM for processing. So I took the advantage of that Google Cloud. And then the data is divided into training and test set, and it is divided in the ratio of 18:20. So this is the comparison. As you can see, the data, the result is evaluated based on R-square, MAE, MSE, and RMSE. So here you can see, means I have taken 5 meters, and to secure the privacy of the customers, I have given just meter number M1, M2, M3 instead of giving the actual company name or the meter number. So here I found that random forest is giving best result on all the parameters, R-square, MAE, MSE, and RMSE. So this is it. So we can see here graphically also. Here DTR means decision tree regressor and linear regression and RF. So RF, random forest, is giving the best result on all the 5 meters. See, here I would like to mention that I clustered my data so that I can have all the type of consumption, like because consumption is somewhere it is high, somewhere it is low. So I have clustered it and tried on all types of all consumption patterns. So in all consumption pattern, you can see that RF is giving the best result. This is for R-square. And then I compared it on RMSE, and RMSE, you can see that on all meters, this RF again is giving the lowest error. RF is giving the lowest error. Then I found that best result came from random forest, and then I compared, then I ran the same data on LSTM also, and I got that when I'm comparing RF and LSTM, LSTM is giving far better result as compared to random forest on all the parameters like R-square, MAE, MSE, and RMSE. So we can see here in graph, here see RF and LSTM. So R-square, this is related to the accuracy. So it is giving the best accuracy on all the 5 selected patterns or clusters, you can say, on customers. And then I compared it with RMSE also, and here you can see that LSTM is giving far better results as compared to random forest. Here, and now the conclusion and future work. On all the metrics, the RF model proved to be the best in comparison with LR and DTR. So RF gives a better accuracy rate with a very less RMSE score. See, when I compared it with machine learning models, and then comparison of RF with one of the popular deep learning model, LSTM and RNN, for predicting energy consumption. So when I compared RF with LSTM, so LSTM RNN is giving the better result. So the metric to evaluate models were the same for both comparisons. And it was found that LSTM RNN proved to be superior to all the metrics. So we can conclude that while predicting energy consumption, LSTM RNN is the best model to be used. And it is for the short term. The prediction is for short term. And the research will further move towards, this is my future work, employing various other LSTM models to improve the accuracy of prediction, such as GRU units with LSTM, feed-forward neural networks, LSTM with a stochastic gradient descent technique, and back propagation and CNN. So these are the other methods in deep learning which we can use to improve the accuracy, and this will be my target to try these models to improve the accuracy of my result. So thank you very much. And this is all about my paper. And if any questions, I'm ready to answer.
Any questions from the audience? I am happy with your work, Bhavna.
Thank you very much, madam. It's all about your support.
See, the scholars, what the research as they are doing is, it is going to helping to the society. That is here in your work, electricity demand forecasting you are performing, isn't it?
Yeah, ma'am.
Yes, yes. That too, you took the data from Himachal Pradesh electricity.
Yes, ma'am. It's a real-time data, madam.
Yes.
For 2 years.
Right, right. Even you can extend this work, like where actually we have to predict the demand in the different states of Andhra Pradesh, in the different states of India.
Yes, ma'am. Yes, ma'am. It can be used.
Yes. Okay. No queries from the audience, I think.
Yeah.
Right. We are stopping this session. And
ma'am, should I stop sharing?
Yes, yes.
Okay. Thank you, ma'am.
All the participants, delegates, audience, whoever are here, that is, we are closing the session, and afternoon from 2 to 3, Mr. Mohammad S. Obedar, he is going to give his keynote speech. Okay, then followed by the rest of the candidates from the session 1. We are stopping here.
Okay. Thank you, madam. Thanks a lot. Thanks, everyone.
All of you may leave this Zoom session.
Okay, ma'am. Thank you.
బాగా జరిగిందమ్మా.